Okay, so today we are going to start a new topic, okay, that is modulation. Okay, modulation. And also we can say that demodulation, modulation and demodulation. Okay, okay, so okay, so I will consider a very simple example, okay, very simple communication system. Simple communication system. You can see my writing, no? Can you see my writing? Okay, okay, thank you. Thank you. Let's say that so first that I think you know what is communication. Okay, so we are talking about actual telecommunication, well, distance communication. Okay, so here we are learning how informations. Okay, how informations information uh, transferred. Okay, can be transferred from one place to another distance place. Okay, okay. So that is communication, not telecommunication. No? Okay. So here we are talking about that kind of communication system. Okay, and we are using electrical mean. No, we are using electrical mean. Okay, we are using electrical mean to communicate our information. Okay, so we can do the telecommunication in various ways. No? Without using electronics or electrical mean, we can communicate. Okay, in old days, peoples were doing the communication. They don't use, they didn't use this electrical mean, but they have somehow communication, no? Using fire or something, using animals. Maybe they have done the communication, telecommunication. Okay, but here we are talking about uh, communication, distant communication with the means of electrical. Okay, so actually this is started from Morse code. I think you have know about this. Okay, so I think this communication is this electrical mean communication is started when once uh, the scientist has founded the electromagnetic effect. Okay, so it is starting with Morse code. Okay. Okay, so actually now we are not talking about that. Okay, so I need to tell you what we are doing here. Okay, that is why I told this information. Okay, okay. Anyway, okay, so I will consider very simple communication system. Okay, here we want to send some information from one end to another place using electrical mean. Okay, okay. So let's say that some people is talking. Okay, so some people is talking. Okay, so this is the mouth. Okay, and some person is talking. Okay, and so so this is a voice. Okay. So this is voice. Okay, and if you want to send this voice through a electrical mean to distance, what is the first thing you should do? Can anyone tell me? If you want to send this voice to some distance, to far away, okay, using an electrical mean, okay, using an electric signal, okay. I don't know the word is correct or not 100%, okay. So what is the first thing we should do? This is voice. Okay. So if you want to send this through electrical mean, what is the first thing we have to do? Can anyone feedback, please? You have to convert this voice. Yeah. Yeah. So actually, what is we? Yeah, you mentioned the instrument. Okay. Okay. So first we have to convert this voice into a electrical signal. No, we have to convert this voice into a electrical signal. Otherwise, we can't send it through a electrical mean. No, electrical means maybe a cable or another medium. Okay, electrical medium, electrical or magnetic medium. Okay. So anyway, first we have to convert this voice into an electrical signal. No? For that one, you can use a microphone. Okay. Okay. Say that you have used a microphone. Okay. So what is the output of this microphone? Can anyone tell me what is the output of this microphone? What is the output of this microphone? The input is voice. Input is voice. And what is the output? Can someone feedback, please? Yeah. Yeah. You can say it's a audio signal. Okay. I will refer it as electrical signal. Okay. I will refer it as electrical signal. I think that is also okay. 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 So we have electrical signal and it is in audio range. Your answer is correct. Okay. So this signal is in audio range. Okay. So this is a signal. Okay. This is a signal. That means it is a time varying voltage or current. Okay. It is a time varying voltage or current. Okay. Let's say that it is a voltage. Okay. So voltage may be changing like this. Okay. We don't know. It is somehow changing like this. Huh? It is a arbitrary signal. We don't know what is that. Okay. So, so, so if I ask what is the frequency range of this signal, can you tell me? Okay, I think you have know about the frequency. You have learned these things, this stuff in signal and system subject. Okay. So if I ask from you, what is the uh, frequency range of this electrical signal? Do you know that one? Can anyone feedback? So this is audio signal. Okay. This electrical signal is audio signal. Okay. It is in audio range. Okay. It should be in audio range. Okay. It is a signal that means it is varying that voltage or current varying with time. Okay. So there is a frequency of varying. No? Frequency means number of cycle per second. Okay. So what is the frequency of this signal? Actually, we have a frequency range here. because you can see that this signal is not a signal is not a fundamental signal. Okay, sine signal, sinusoidal signal. It is a complex signal. No? We can't say it is a complex signal. Okay, that name is wrong. Okay, it is an arbitrary signal. Okay. Okay, so we can't say that we have only one frequency for this signal. Okay, so there should be some frequency component with this signal. Okay, there can be many frequency component with this signals. Okay, so that frequency component will lie between 0 and 4 kilohertz. Okay, so that is the range for audio signal, 0 to 4 kilohertz. Actually, uh, it is around 3.4 kilohertz, as I can remember. Okay, 3.4 kilohertz. Okay, so anyway, you can check it in the internet. You can Google it and get the accurate value. Okay, but this idea is enough. Okay, this idea is enough. Okay, so we have some frequency component with this audio signal. It is not a single frequency. Okay, it is not a single frequency. This information will be important later. Okay, when we are analyzing the modulation schemes, these informations are very important. Okay, so that is why I am telling. So try to understand these things. Okay, uh, so already you have learned the signal and system stuff. Okay, so I think you know that, you know these things. Okay, so this has some frequency component. Okay, in other way, we can say that this signal is made up with several sinusoidal signals. Okay, this signal is made up with several sinusoidal signals. We can interpret like this. Okay, so the frequency component will be 0 to 4 kilohertz. Okay, so we can simply say that this electrical signal, this audio signal is between 0 to 4 kilohertz range. Okay, 0 to 4 kilohertz range. Okay, okay, now, okay, I will remove this. Okay, so here we have voice. Okay, voice, and here you have the microphone. Okay, microphone. So the output of the microphone is electrical signal. Electrical signal. What is the frequency? It is 0 to 4 kilohertz range. Okay. Here it is not a single frequency component. Okay. It is not a single frequency component. We have several frequency components that that frequency component lie between 0 and 4 kilohertz. Okay. 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 Now say that you want to send this signal, around 2 kilometers. Let's say that you want to send this signal 2 kilometers. Okay. Okay. So you know that this is an electrical signal. Okay. So if you use a copper wire, if this is a copper wire, can we send this signal through this copper wire? Can you answer yes or no? Can we send this signal through copper wire without doing any modification, without doing any processing? Can we send this electrical signal? So this is a voltage, no? Electrical signal means current or voltage, time varying current or voltage. Okay. So can we send this through a copper cable? If you have a copper cable, can we send? Can someone feedback? Yes or no? Yeah. So why? Yeah. Yes. Yeah. Actually, we can send, no? We can send. Yeah, I think some student has answered no. Okay. So I know that they have some other things in their mind. Okay. Attenuation, these things, amplification, these things. Okay. So just ignore these things. Okay. So this is a electrical signal. Okay. So it is a voltage. And if you have a copper cable with the proper gauge, okay, you can send this signal through that copper cable, okay, to 2 kilometers. Okay. So actually here we have to use two cable, no? We have to use two cable. Why we need two cable? Can anyone tell me? Why we need two cable, two copper cable? Yeah, very good. Yeah, actually that is plus and minus, no? Yeah, someone, yeah, no, it is not transmission receiving transmission. That is not for transmitting and receiving. Actually, that is plus and minus. Okay, that cable is for plus and minus. Okay, so if you want to, so this is electrical circuit, no? This is electrical circuit, and you know that. So if you have an electrical circuit like this, simple electrical circuit, okay, here you have a bulb, okay, and you have a switch, okay, and this is plus and minus. Okay. So you can see that if you want to send a current through this electrical circuit, you have to switch this. Okay. That means you have to have a complete loop. Okay. So there is a plus line and there is a minus line. Okay. So so that will complete the electrical circuit. No, otherwise a current will not flow through this circuit. So it will not work. Okay. So that is why we need to have two cables. Okay, that is not for transmission and receiving. If you want to transmitting and receiving, you have to use two pairs. Okay, you have to use two pairs. Okay, so for transmitting, you have to use two cable. That means one pair. Okay, so you have to use two cable. Okay, so one is plus and other is the minus. Okay, and you can lay these cables to 2 kilometers. And if you have a speaker there, okay, speaker there, you can connect it to plus and minus of the speaker. Okay, so that will complete the electrical circuit. No, this current go through this and it go through a speaker and it is again come here. Okay, so it is the electrical circuit is completed. Okay. So likewise, you can send this voice up to 2 kilometers using copper wire. Okay. And so input to this speaker is electrical signal, electrical signal, okay, electrical signal, and output will be again voice. Okay. So if someone is here, okay, if someone is here, if some person is here, okay, to listen to that voice, that man can hear that one, no? Okay. So here the output is a voice. Okay. So likewise, we can do a communication from one end to other end using the electrical mean. Okay. So if you want to do a two-way communication, here also you have a mic and this side you should have a speaker. Okay. Actually, your telephone is like that, no? You have a mic and you have a speaker. Okay. So your telephone can do both transmitting and receiving or two-way communication. You can talk and you can listen at one end because there is a microphone and there is a speaker. Okay. Okay. So for simplification, we will consider only one-way communication. Okay. Only one-way communication. Okay. So here you can see that this copper cable will send this signal to this speaker and you can hear the voice. Okay. And you know that when the signal is traveling through this cable, there can be some attenuation. I think you have already learned these things. Okay. Uh, and some noise can be added to this uh, communication line. Okay. To this electrical signal. Okay. So you have to overcome these things and you have to introduce several blocks. Okay. Several blocks, several additional blocks to this communication system. Okay. Likewise, you can make a complete communication systems. Okay. But this also a simple communication system. You have a transmitter here. You have a transmitter here. And you have a receiver here. And you have a transmission media. Okay. You have a transmission media. So the most basic components are there, no? Transmitter, transmission media, and receiver. Okay. So if you want to improve the quality, you have to add several blocks. Okay. So don't get confused with your, maybe you have learned the communication system. Okay. The theoretical communication system, there are many blocks rather than transmitter and receiver. That is for improving the quality of the transmission. Okay. Transmission and receiver. Okay. So, so these are the essential things. Okay. Transmitter, transmission media, and receiver. Okay. So we can do this communication, no problem. Okay. 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 Now, let's say that we need to send this signal. Again, this man is talking. Okay. This man is talking, and you have a microphone. Okay. Let's say that you want to send this signal. You don't have copper wires. Okay. You need to send this signal through wireless medium. Okay. Through a wireless medium. So here you use in a guided medium. No, this is a guided medium. This is a guided transmission medium or wired transmission medium. Okay. Let's say that you need to transmit this signal to 2 kilometers without wire. That means wireless. Okay. So you need to have a wireless communication. You need to transmit it without wire. Okay. Okay. For that one, okay, you can use, okay, you can use electromagnetic wave. You can use electromagnetic wave. Okay. You can use electromagnetic wave. Okay. So anyone have an idea how can we convert this electrical signal? So we have an electrical signal, no? It is not an electromagnetic wave. It is just an electrical signal. If you want to send this through an electromagnetic wave, you have to convert this electrical signal. Okay. So you have to convert this electrical signal into an electromagnetic wave, no? Into an electromagnetic wave. Let's say that like this. Okay. This say you have to convert this to an electromagnetic wave. Electrical signal to the electromagnetic wave. Can any student tell me how can we convert a electrical signal to a electromagnetic wave? Using what? So here you use microphone. You convert voice to electrical signal. Now you need to convert this electrical signal into electromagnetic wave to propagate it through a space without cables. Okay. So how can we convert this electrical signal to a electromagnetic wave? Anyone have idea? Yes, very good. What about others? I got only one answer. Okay, I got only one answer. That is correct. And what is the things we need to do this conversion? Anyone can answer? Not anyone. One already one. Any other student can answer? Already one student gave the correct answer. Anyone? Hello, Lahiru. No. Okay. Okay. Uh, yeah, that is also a correct answer. Okay. But here we are not talking about laser communication. Okay. Okay. Anyway, thank you for your answer. That is also correct. Okay. We can use laser. Okay. Uh, rather than not rather than using. Okay. Instead of this electromagnetic wave, you can laser is also electromagnetic wave. Okay. Uh, so that is in another frequency range. Okay. We will come to that point later. Okay. So you can use that one also. Okay. You can use a laser source to convert this electrical signal to a laser beam. Okay. But I want to convert this to a electromagnetic wave. That is also a laser is also electromagnetic wave. Okay. But I need to convert this into a low frequency electromagnetic wave. Okay, laser is somewhat high frequency one. Okay, so we will come to that point. Okay, maybe some of you couldn't understand these things. Okay, but we will come to that point later. Okay, okay. So if I want to simply talking, if I want to convert this electrical signal into electromagnetic wave, you can use an antenna. Okay, so you can use antenna. Okay, you can use antenna. Antenna is nothing but it is a simple conductor. Okay, conducting rod. Okay, so if you feed the signal to the antenna, okay, if you feed the electrical signal, to antenna, okay, so you know that current will flow through this conductor. Okay, current will flow through this conductor. Current means nothing but charges, no? It is charges, plus or minus charges. Okay. So normally we consider the current flowing direction is the plus charges flowing direction. Okay. So current is nothing but moving charges. Okay. So you know that if the charge is there, you will have an electric field. If the charge is there, you will have the electric field. You have learned this in your A level also. I think you have another subject, electromagnetic, no? Electromagnetism in that subject. Also, you have learned these things, okay? So if there is a charge, it creates an electric field. And if this charge is moving, it creates a magnetic field. Simply talking, okay? It creates a magnetic field also, okay? So, you know, so we can see that if 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 we can make uh, a current flowing through a conductor, it will create an electric field as well as it will create a magnetic field. Okay, so it will create electromagnetic field. Okay, and that is changing. Okay, that electric field and magnetic field is changing, so that it will be traveling. Okay, it will be propagating. Okay, if you can't understand that physics things, it is okay. Okay, we don't need that knowledge for this course. Okay, but if you have a general idea, that will be enough. Okay, so you can see that. I think you already know that if this electric field and magnetic field is changing, it is propagating, because change in electric field will generate a magnetic field. Change in magnetic field, that change in magnetic field again generate a change in electrical field. Likewise, it is propagating through space. Okay, so it is propagating, it is traveling from one point to other point. It is propagating in its space. Okay, so you have an electromagnetic wave. Okay, so if you use antenna, if you feed this signal to antenna, so you have an electrical signal here, and if you feed this signal to antenna, you will have a electrical electromagnetic wave. You will have a electromagnetic wave. The antenna will give you a electromagnetic wave. It couples this electrical signal into electromagnetic wave. Okay, so this electromagnetic wave is propagating. Okay, can anyone tell me what is the difference between electrical signal and electromagnetic wave? Actually, signal is not propagating in space. Okay, so the signal is just a time varying voltage or current. Okay, so this electrical signal mainly depend on time. Okay, but electromagnetic wave is changing with time and also change in its position. That means it is changing with respect to space also. So this is a variable, okay, that depend on the space as well as time. Okay, so that is the difference between electrical signal and electromagnetic wave. Okay, signal is just a time varying one, depend on only time, only one variable, but electromagnetic wave will depend on space and time. Okay, okay. So now you can feed this signal to the antenna. Okay, and it will propagating. It is an electromagnetic wave. No, it is propagating to environment. And if you have antenna there, okay, if you have antenna there, you can, using this antenna, you can convert this electromagnetic wave again to electrical signal, and you can feed it to the speaker. Okay, in this way you can do a wireless communication. Okay, so this is a wireless communication system, simple wireless communication system. Okay, okay. So anyone can tell me, um, is this okay? Can anyone tell me, is this okay or not? Okay, actually, theoretically, this is okay. Okay, theoretically, this is okay. But practically, we have to face some problem. Okay, we have to face some problem. Okay, so what are the problems? Okay, one thing is, so you can see that if we need to do a wireless communication, okay, if we need to do a wireless communication, okay, definitely we should have antennas. Okay, we should have antennas. Okay. So if you want to do a, if you want to achieve a wireless communication, you have to construct an antenna. Okay. So there are many antenna types. Okay. And all antenna depends on the lambda of the electromagnetic wave. Okay. Lambda of the electromagnetic wave or signal. Okay. Lambda means wavelength. Okay. Wavelength. Okay. So normally antenna, the size of the antenna will depend on the wavelength of this signal. Okay. The wavelength of this feeding signal. Okay. So if this wavelength is very high, okay, you need to have very big antenna. Okay. If that wavelength is very low, the antenna will be small. Okay. So that one also I think better to keep in your mind. Okay. If lambda wavelength is increasing, okay, the size of the antenna also will be very big. But lambda is decreasing. If you have very small lambda, size of antenna will be very low. Okay. So if you, okay, I will give this exercise later. Okay. So if you calculate the lambda, so you can see that this is a voice audio signal. The maximum frequency component is 4 kilohertz. Okay. So that is the maximum frequency component we will have. Okay. And we know that there is a relationship that V equal F lambda. No? You can see that if F is increasing, lambda will be low. Okay. Lambda will be very low. If the, sorry, if F is this increasing, if F is increasing, the lambda will be decreasing. Okay. I'm sorry. Okay. You know that V equal F lambda. If F is increasing, lambda will be decreasing. Okay. So, so you can see that. So this is the maximum frequency component you can have in your voice audio signal, 4 kilohertz. Okay. So that will be the, that will give you the minimum lambda. No? Okay. So you can see how much the minimum lambda. How much the minimum lambda using V equal F lambda. Okay. I will give you to do this one. Now you know me. You will have this lambda for several kilometers. Okay. You will have this lambda several kilometers because this V is, you know already, that is the velocity of light. That is 3 into 10 to the power 8 meter per second. Okay. So this is in kilohertz range. Okay. That means 10 to the power 3 hertz. Okay. So you will get lambda for several kilometers. Okay. So if you want to do this communication, okay, if you want to do this communication, you should have to use very big antenna with several kilometers. Is that practical? No, it is not practical. Okay. So if you are using wired, if you are wired to communicate, you no need to do anything. Maybe you have to do amplification. Okay. Because there are some attenuation. Okay. And sometimes you have to do a amplification. Okay. But if you use wireless medium, that means if you are using electromagnetic wave, okay, you have to use, you have to use the antenna, okay, okay, to get a practical size antenna, you have to convert this electrical signal into in that range. Okay. So simply speaking, you have to increase this electrical signal into a higher frequency. Okay. Can you understand what I'm talking? Okay. Okay. So I will tell it again. Okay. So that is the point actually. I want to come to that point. Okay. So, so you have a electrical signal. Okay. Electrical signal that is in 0 to 4 kilohertz range. Okay. And if you use antenna to propagate this signal through wirelessly, you have to make that antenna with several kilometers. Okay. You have to use, you have to construct that antenna with maybe 10 kilometers, 4 kilometers antenna. Okay. So that is not practical. Okay. So you have to, if you convert this frequency to a higher frequency value, to higher frequency value. So the frequency is high, then lambda will be low. Okay. So that means you can make very little antenna, practical size antenna. Okay. So you have to do this frequency conversion. Okay. You have to do this frequency conversion. Okay. Actually, that is we called as modulation. Okay. That is we called as modulation. Okay. So now, can anyone tell me why we need modulation? Okay. If I, so I have told you a big story there, no? Okay. But if you summarize that story, okay, what is modulation? What is modulation and why we need this modulation? Why we need this modulation? Okay. Okay. So try to summarize. Okay. What is modulation and why we need this modulation? Okay. Okay. I think now you can answer these two questions. Okay. Up to this point, this will be enough. Okay. If you could answer this question, you can, it is enough. Okay. So this question is in your tutorial. Okay. I have given. Okay. So I am not telling anything. You can write the answer for that one. Okay. I will be given that tutorial, that assignment to you. Okay. In near future. So you have to answer this question. Okay. So I think you can answer this question. Any problem? Any problem up to this level? Up to this point? Okay, if you don't have any problems, we will move forward. Okay. Okay. Now we know what is modulation and why we need modulation. Okay. So yeah, yeah, your answer is correct. Okay. Yeah, yeah. Thank you for the answer. Okay, that is 100% correct. Okay. Uh, yeah. Okay. I think you have some prior knowledge. Okay. Some terms still we didn't use. Okay. Anyway, that is a complete answer. Okay. Thank you for that. Okay. So we will move forward. Okay. One thing I forgot to tell you. Actually, I remember it because of your answer. Okay. This signal, this signal. So this signal is in 0 to 4 kilohertz. That means it is very low frequency. It is low frequency signal. Actually, I think it is very low frequency signal. Okay. If you uh, check the spectrum, electromagnetic spectrum, this 4 kilohertz include in VLF range, very low frequency range. Okay. So this signal, this information, this has information. No? This low frequency signal has information, and we called it baseband signal. Okay. And we called it baseband signal. Okay. We will learn this later more. Up to this level. Okay. This idea is enough. Okay. So this signal is the baseband signal. Baseband signal. That is nothing but your voice signal or audio signal. Okay. That is audio signal. Okay. And it is low frequency signal. Okay. Low frequency signal. Okay. 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 Actually, in modulation, we are converting this baseband signal into higher frequency signal. Okay. Higher frequency signal. Okay. So this frequency range, this conversion frequency range, we call that as RF frequency, radio frequency. So radio frequency range. Okay. Radio frequency range. Okay. So this is actually baseband signal is in audio frequency range. Okay. That is 0 to 5, 0 to 4 kilohertz. Okay. And by modulating the signal and using the modulation, we convert this low frequency signal or baseband signal into a higher frequency range, that is in RF range. Okay, radio frequency range. As I can remember, it is from 50 megahertz to around 4 gigahertz, as I can remember. Okay, so you can check these values are correct or not. Okay, you can Google and check me. Okay, but if you have the idea, I think that is enough. Okay, you no need to know the exact value. Okay, but for your information, you can check it. Okay, so actually we are doing these things. We converting baseband signal into a higher frequency signal. That is a radio frequency range. Okay, so that is called modulation. Actually, that is called RF modulation. Okay, because we are converting this signal into RF signal. Okay, so if you can convert your audio signal into maybe for a visible light range. Okay, or as one student told, for a laser range. Okay, so that is very high frequency. Okay, but that is not RF modulation. We called it if it is laser, we called it optical modulation actually. Okay, we called it optical modulation. Okay, so in this course we are not focusing on this part in optical modulation, but the concept is same. Okay, but we are mostly focusing on this RF frequency range. Okay, so mostly we are focusing on RF modulation stuff. Okay, so that is the idea you should have. Okay, okay. So if we consider the modulation, okay, uh, we should have an information signal. Okay, we should have an information signal. Okay, and we have to use another high frequency signal, no? Okay, another high frequency signal. We called it carrier signal. Okay, we called it carrier signal. Okay, so this information signal is the baseband signal. Baseband signal. Okay, and this higher frequency signal is the carrier signal. Okay, so this is the carrier signal. Okay, so this is higher frequency signal. High frequency signal. Okay, so if you use the carrier signal in RF range, that is from 50 to 50 megahertz to around 3 gigahertz, around 4 gigahertz. We called it carrier RF modulation. Okay, so if you choose this carrier signal in laser range, okay, so we called it optical modulation. Okay, but here we are mostly focusing on RF modulation, but the concepts and theory are same. Okay. Okay, so you can see that you have an information signal and you will have a carrier signal. Okay, to do the modulation, these two signal you need to have. Okay, baseband signal and carrier signal. Okay, okay, and okay, tell me. So we have considered this communication system. No? We have considered this communication system. Okay, so this is a simple communication system. Okay. So, can anyone tell me this, our voice signal? Our voice signal is analog or digital signal? Is this an analog or digital signal? Now, I think you know what is an analog signal and what is a digital signal because you have learned these things in signal and system. Yeah, that is analog system. Okay, that is analog system. Thank you. Okay, so can anyone tell me what is analog signal? Can anyone remember? What is analog signal? Okay, analog signal is nothing but, okay, signal is, as I told you, it is a voltage or current varying with time, okay. So analog signal means if you consider any two amplitude, okay, higher and lower amplitude, okay. So between these amplitude levels, okay, there are all the values available, okay. So that means if you have infinite number of amplitude level between two amplitude level, okay. So that is called analog signal, okay. But if you if any signal is there like this, okay, and if you consider two amplitude level, okay, okay, but if you have very few amplitudes level between these two amplitude, okay, here you have 1, 2, 3, 4 amplitude levels, okay. So that means you can count that amplitude level, okay, okay. So that kind of signal we called as digital signal, okay, digital signal. So if you have infinite number of amplitude levels, that is analog signal. If you have countable or finite amplitude level, that is a digital signal, okay. So I think you have learned these things in the signal and system, okay. That knowledge uh, is required for this part actually, okay. Okay. Uh, so you know that, okay. Uh, you know that uh, I think you have learned about digital system and analog system, and you already learned about digital communication system and analog communication system. Okay, so there are some advantage and disadvantage using analog and digital system. it depend on the application actually. Okay, but if we generally talk, okay, the modulation, sorry, the digital system may be more efficient. Okay, so nowadays most communication systems are digital communication system, but it is not 100% correct. Okay, sometimes we use some analog communication systems also. Okay, so anyway, what I want to tell you is that, okay, if you are using analog system, this information signal can be analog. Okay, and if you are using digital signal, this digital system, this information can be digital. Okay, so this baseband signal can be analog signal, this baseband signal can be digital signal. I think you can understand that one. Okay, as well as, okay, in the same manner, this carrier signal also can be an analog signal, or it can be a digital carrier signal. Okay, so if we want to use the modulation, basically we should have a baseband signal and carrier signal. Now you already know that this is the baseband signal and carrier signal. Okay, and this baseband signal can be analog or digital, and also this carrier signal also can be analog or digital. Okay, that is also depend on the application. Okay, so using this based on this information signal and carrier signal type, we can classify the modulation into many parts. Okay, okay, so you can see that we have some analog and digital information signal, and we can have analog and digital carrier signal. Okay, okay, so based on the type of baseband signal, I said BS, and carrier signal, we can classify the modulation is. Okay, so modulation can be classified with respect to different parameters. This is one classification. Okay, this is one classification. Okay, you know that if you consider the human in the world, you can classify them depend on many factors. Okay, you can use color, you can classify them into different color. Okay, if you use the fact maybe the attitude, maybe you can classify the people into good and bad people likewise. Okay, so depending on many facts, you can have several classification. Okay, so this modulation also will have several classification. Okay, so this is one classification. Okay, I think you better keep this in your mind. Okay, this idea, that will be enough. Okay, so based on the type of baseband signal and carrier signal, you can classify this modulation into several groups. Okay, into several parts. Okay, so uh, so this classification may be not 100% correct. Okay, but if you have this, you can get the idea. Okay, but if you refer the internet or many books, sometime uh, they they have classified these in another way. Okay, this in another way. Okay, that is why I told you there are several classification based on the several fact. Okay, okay, so there is no any unique classification. Okay, okay, so there can be several classification. Okay, so in our course, we will classify this modulation like this. Okay, based on the type of baseband signal and carrier signal. Okay, uh, you can classify it as analog and digital. Okay, analog and digital. Analog means your information signal analog, your information signal also should be analog, and carrier signal also should be analog. Okay, okay. So your information signal analog and your carrier signal also analog. Okay, so you have basically three types of modulation scheme. Okay, basic three types of modulation scheme, that is AM, PM, FM. Amplitude modulation, phase modulation, frequency modulation. Okay, so we called it analog modulation. Okay, okay, and okay, and you can see that this information signal is also analog, carrier signal is also analog. Okay, this is analog. This is also analog. Okay, and also we call this carrier signal, this is analog signal, and sometimes it is referred as continuous wave. Continuous wave. Continuous wave. Okay. CW. Continuous wave. Okay. Continuous wave. Okay. Okay. So that is the analog modulation system. So these are the basic one. Amplitude modulation, phase modulation, and frequency modulation. Okay. And if you consider digital modulation, okay. Okay. Digital modulation. Sometimes digital information we use digital information, but we use analog carrier. Okay, we use a digital modulation, digital information. Okay, okay. We have digital information. Okay, here we have digital information, digital info, and carrier also. Carrier is analog, but analog carrier, analog carrier. Okay. So sometimes your information is digital, but the carrier signal is analog. Okay. So basically you have three modulation scheme again. Okay. That is called ASK, amplitude shifting. That is actually it is similar to AM. Okay, amplitude shift key and phase shift key and frequency shift key. Okay. And normally these are referred as digital modulation scheme. Okay. But remember that ASK, PSK, FSK, only digital informations are digital. Okay. Information, you have digital signal, but your carrier signal is analog. Okay. And another part is there. Okay. So here, your information is digital. Info is digital, and your carrier signals are also digital. Okay. So you have digital info and digital carrier. Digital carrier. I'm not because I am telling this. I am not. I can't clearly write it. Okay. Digital info. Information is digital, and carrier is also digital. Carrier signal is also digital. So you have many modulation scheme here also. Okay. I'm sorry. Okay. So, so you have many modulation schemes related with this part, digital information and digital carrier. Okay. So there are many modulation scheme available. We call pulse amplitude modulation, pulse position modulation. pulse position modulation, PPM, and pulse width modulation. Okay, like that. Okay, so there are many modulation schemes available. Okay, so based on the application and the type of signals we are using. Okay, so uh, so based on the baseband and carrier signal, we can classify the modulation system. Modulation into these categories. Okay, in this course, we are mainly focused on this part. Okay, we are mainly on focus on this part. Okay, we are mainly focusing on analog modulation. Okay. And uh, so there are three types of main modulation scheme, that is amplitude modulation and phase modulation, frequency modulation. So in our course, we are mainly focused on these things only. Okay. In digital communication, you will learn these things also. Okay. These things, ASK, PSK, and FSK. Okay. And I think in digital communication, you have to learn this one also. And pulse position modulation and pulse width modulation, I'm not sure. Okay. But anyway, in our course, we are mainly focusing on this analog modulation is okay. And you can see that carrier signal is analog. Okay. And that is a continuous wave. Okay. That is a continuous wave. So sometimes we refer this as continuous wave modulation. Okay. So we are mainly focused on analog continuous wave modulation, and demodulation. Okay. Okay. So we are mainly focused on these things. Okay. So okay. Before starting this part, okay. Before starting this part, okay. So so we have to mainly learn about amplitude modulation. Okay. And with this amplitude modulation, there are some modified version, and you have to use that one also. You have to learn this one also. Okay. Dual sideband, single sideband, likewise. Okay. And you have frequency modulation, and you have to learn about phase modulation. Okay. So mainly these three things we will learn. Okay. So we will start with amplitude modulation. Okay. We will start our study with amplitude modulation. Okay, before going to the amplitude modulation, I will give you a very simple exercise. Okay. 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 Can you try to do this question? Can you try to do this question? And tell me the answer, please. Okay. So try to do this question before move. Okay. And I think you don't know what is this, half wave monopole antenna. Okay. That means antenna size is lambda by 2. Okay. That is the antenna size. Half wave means that one. Okay. So you have to find the lambda. Okay. And then you have to find the antenna length. Okay. So antenna length is equal to lambda by 2. Okay. So this is the antenna length. So you are asked to find the antenna length to two different scenario, that is for 3.5 kilohertz and for 10 megahertz. So can you try to find this? You have to use V equal F lambda. Then you can find lambda. Then using this, you can find the length of the antenna. Okay. Can you tell me the length for this case and for this case? Let's say this case 1 and case 2. Please send me quickly. Take 5 minutes. Okay, I got some answers. Okay, thank you for the answers. Okay. So I hope the calculation is correct. Okay. Calculations are correct. Okay. So first you have to use V equal F lambda. Okay. V is equal to 3 to the power 3 into 10 to the power 8 meter per second. Okay. Is minus 1. And so this is the frequency 3.5, that is kilo. Okay, that means 10 to the power 3. Okay, equal lambda. Okay, so so this is the you know that this is hertz, no? Hertz means 1 by s. 1 by s. This is hertz. Okay, number of cycle per second. Okay, okay. So you will have s minus 1. Okay. So s minus 1 cancel out, and lambda you will get the length in m. Okay, so that is called wavelength. Okay, so lambda is equal to 3 10 to the power 8 3.5. Okay, so here 10 to the power 3 and you will have 10 to the power m. Okay, so it is in kilometer range, no? Because here it is 10 to the power 5. Okay, 10 to the power 5, and here some values are there. Okay, so it is in kilometer range, around maybe around 50 kilometer. Okay, so this is not practical, no? This is not practical. Okay, you can't use this antenna. Okay, you know it, so you can understand, no? So we can't practically make this angle. Okay, so what we have to do? Okay, so we can convert, if we can convert this 3.5 kilohertz to 10 megahertz. Okay, somehow. Okay, actually we have to use the modulation for this one. Okay, so now the signal frequency is 10 megahertz. Okay, and if you use an antenna, okay, okay, so here antenna should be lambda by 2. Okay, so here maybe 100 kilometers you get. Okay, so antenna length is lambda by 2, and you will get around 50 kilometer antenna. Okay, so that is not practical. And here if you use 10 megahertz, you can say that it is 10 to the power 10 8 10s minus 1 equal 10 into 10 6, no? Okay, into lambda. Okay, so lambda is equal to 3 by this is 7 and this is 10, 3 by 10. Okay, so lambda by 2 you will get around 15 meter. Okay, so you can see that this is also not practical. Okay, 15 meters is also somewhat hard to, we can't say it is not practical. Okay, we can make, but it is hard to make. Okay, it is difficult to construct. Okay, because it is around 15 meters long. Okay, so you can see that if we convert our baseband signal into a higher frequency, your antenna size will be reduced. Okay, so that is the things I want to tell you. Okay, so we will start our study on amplitude modulation. Okay, so we are using amplitude modulation. Okay, amplitude modulation. Normally we call AM. Okay. 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 So, mm, so sometimes we called this. This is under CW modulation or analog modulation, analog CW modulation, continuous wave modulation, and sometimes we call this linear modulation. Linear modulation. Okay. So there are many linear modulation schemes. Okay. And this amplitude modulation is also linear modulation scheme. And we will see what is this. Okay. We will see what is this. This is already, I think you can understand now. Why I call this analog CW modulation? Because carrier is analog and it is a continuous wave. So that is why we use analog CW modulation name, that name. Okay. And still you don't know what is linear means. Okay. We will see it later. Okay. Why we call this amplitude modulation as a linear modulation. We will see it later. Okay. But try to remember these things at this point. Okay. Okay. So we will move forward. Okay. Okay. Now uh, we are talking about analog. So here we are. So this actually this analog means the carrier also analog and information also analog. Information also analog. Information also analog. Okay. So in amplitude modulation, we know that carrier is analog. Okay. And information or baseband signal is also analog. Okay. So carrier signal is analog and baseband signal also analog. Okay. Okay. So normally, you can see that this information signal we can't determine. This is we can't determine. Okay. This can be a random signal or arbitrary signal. We don't know what is the signal. Okay, we can't determine. Okay, we can't determine this information signal. Can't determine. Okay, because if someone is talking, okay, so you will have this kind of arbitrary signal. Okay, and we don't know this signal type. Okay, because we can't determine. Or we can say that it is a random signal, sometime, okay, not always, okay, and sometime it will be arbitrary signal, Definitely it is an arbitrary signal. But this carrier signal is not depend on the information, no? So this baseband signal is depend on the information. If you talk something, you will get some signal, and if another one talk something, you will get another signal. No? Okay. So this signal is not deterministic. It is changing this information. Okay. But we can fix this carrier signal, no? Because this is generated by us. Okay. So this carrier signal can be generated as we wish. Okay. So normally we can generate this carrier signal as we wish. Okay. And I think you know that RF signal, okay, or electromagnetic wave. Electromagnetic waves are sinusoidal in nature. Okay. maybe you know this already because you have done the electromagnetism. Okay. So this one point is we can generate this carrier signal as we wish. Okay. So you can get a square wave as the carrier signal. You can get sawtooth wave like this. Maybe you can get sinusoidal signal. You can get any signal. Okay. So you can determine, okay, what is the signal you are going to use as the carrier signal. Okay. So you can use any signal. Okay. But you know that if we consider the electromagnetic wave, electromagnetic wave, these are normally sinusoidal in nature. Okay. Sinusoidal in nature. Okay. Those are normally sinusoidal, electromagnetic wave. Okay. So we wish to use, okay, we wish to select this carrier signal as a sinusoidal signal. Okay. So that is the point. Okay. But but we can't determine the information signal, no? Is that clear? We can't determine the information signal, but we can determine the carrier signal. Okay. Is it okay? So the electromagnetic waves are normally sinusoidal in nature. So we wish to have sinusoidal carrier signals. Okay. So that is the point you should understand. Okay. So in other words, okay, in other words, we like to have sinusoidal carrier signals. Okay. So normally we select the carrier signal as sinusoidal signal. Okay. But sometimes you can experience that you will have some other signal also as the carrier signal. But for normal communication system, we are using sinusoidal carrier signal. Okay. I think it is clear. Okay. If you have any problem, you can ask. Okay. You can interrupt any point, any time, and you can ask. Okay. Okay. So, okay. Now I think, can you remember the sinusoidal signal? So we have to, so for carrier signal, we are using sinusoidal signal. Okay. And these information signals are random, normally, random in nature. Okay. But for calculation simplicity, we are selecting this information also as sinusoidal signal. Okay. Don't confuse. That is not the real situation. Okay. But for our analytical and calculation purpose, okay, we use sinusoidal baseband signal only. Okay. So normally we are dealing with the sinusoidal signals. Okay. For calculation and for analytical, but that is not in real communication system. I'm sorry. Give me a moment. Okay, I'm sorry. Okay. Okay. So, so we will. So I think you have learned about sinusoidal signal in signal and system. Okay. In signal and system, you have learned this, about sinusoidal signal. I think you have to use that knowledge here also. Okay. Okay. So, first one is sinusoidal signal we can represent like this, no? I think you can remember that. Okay, let's say that xt. So this is time varying signal. It is the function of time. Okay, and it is, we can write like this. Plus omega t plus 5. Okay, can you remember that? We can write, we can we can mathematically represent a sinusoidal signal like this. Okay, and what is this? This is amplitude. This is frequency, and this is phase. Actually, this is angular frequency. No, this is angular frequency. Okay, this is angular frequency, and angular frequency is equal to 25f. Okay, so this is angular frequency, sometimes called angular velocity. Okay, angular velocity. And this is the normal frequency, hertz. Okay, this is the frequency, hertz. Okay, so this is measured in hertz. Can anyone tell me what is this measured? This omega is measured from what? Can you remember? In signal and system, you have learned this. Please tell me. Omega is equal to 2πt, no? 2πt. This t is the period. Period of a sinusoidal wave, sine wave. Period of a sine wave. So what is the unit for the omega? Can anyone tell me? So today I think it is not enough to start the modulation scheme. So we will try to refresh our memory on this sinusoidal signal. I think that that information, yeah, very good. That is radian per second. Okay, thank you for the answer. Yeah, because this 2.5, this is an angle. Okay, this is an angle measured in radians. This is a period, time measured in second. Okay, so the unit for this omega is radian per second. Okay, and this is hertz. Okay, so it is relating like this. Okay, and this phi is the phase. Okay, the starting point. Okay, okay. So if I show you, okay, so so this signal will look like this. Okay, the signal will look like this. Okay, so you have some phase, and it is like this. Okay, it is like this. Okay, and this is A. So that is the maximum amplitude. No? That is the maximum amplitude. And this will be minus. Okay. So peak to peak is 2A. No? Peak to peak is 2A. Okay. And this peak to this peak. Okay. This peak. Okay. This time we called as period. No? Period. Time per one circle. One cycle time. One cycle time. This is one cycle. Okay, this is one cycle. You better refresh these things. Okay, this is one cycle. Okay, and this is one cycle time duration. Okay, so one cycle you will have 2.5 radian difference for one cycle. Okay, one cycle means 2.5 angle, and that is, so this is the time for one cycle. Okay, and you will have the angular velocity. Okay, and this starting point, this, okay. So you will have some shift here, okay. So it is also happen in time, okay. But this is the phase shift, okay. So, okay. So if this 5 is set to 90, 5 is set to 90, it will be a sine signal. So it will be a sine 5t. Okay. So it will be like this. Okay. It will be like this. Okay. It will be like this. Okay. So this is a sine, and it is a sinusoidal signal. So this is based on phase. Okay. So these things you should know. Okay. So if I show you it in MATLAB, okay. 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 So so if you plot some sinusoidal signal in MATLAB, okay. So I think you have you learned about have you learned the MATLAB previous? I think one course is there, no? You have learned MATLAB. Okay. So I'm not going to actually this is not relevant to our course. Okay. I'm going to do I'm going to show some waveforms. Okay. Using MATLAB. Okay. So I explain how to write. Okay. These things also. Okay. And in MATLAB, okay. MATLAB so I have told you that uh, so this is a sinusoidal signal, okay. So this is a sinusoidal signal, okay? This is a sinusoidal signal, and you can see that this signal can be what is called can be uh, characteristic using these properties, okay. Using these properties, amplitude, frequency, and phase, okay. And these are not changed, okay. This amplitude and omega and 5 not change. The signal is changed. It is changing with respect to time, okay. But this amplitude, omega and 5 is not changing, it is fixed, okay. So we called it deterministic signal, okay. It is not changing time to time, okay. So you will get a same shape, okay. It will not change, okay. Okay. So so characteristic, I think this stuff you have learned in your signal and system subject, okay. So I think you know that you have learned about the random signal and deterministic signal. So this is a deterministic signal, okay. So for this deterministic signal, the signal can be analyzed in using this equation. This signal identity or equation, you can analyze the signal if it is a deterministic, okay. So in MATLAB also, you can, this is a deterministic signal, and you can write or you can draw the waveform using that equation, okay. So I write that equation here, okay. So equation is nothing but x, no? Let's say that xt is equal to, okay, uh, there is a value a, no? So here you have to put some value, okay. So I put 2, okay, and you have cos, okay, and omega also you have to give some value, okay. Omega also you have to give some value. So I will put 6, okay. So that is the frequency, angular frequency, and it is multiplied by t time plus some phase, okay, like this, okay. So this is a signal, okay. So you can code it in MATLAB directly because this is a deterministic signal, okay. So rather than using some value, you can assign some variable, So amplitude is here 2, okay, and omega is here, okay, 6, no? Okay, and phase, let's say that q is phase, okay, is 9, okay, like this. And you can put that value also here without using that number. You can put this variable a, w, and q, like this, okay, like this. Now if you want to draw this signal, okay, if you want to draw this signal, you have to get some time value, okay. So that is the normal way to draw the waveform, no? Okay, so you know that, okay. These are mathematics. In O-level mathematics, we have learned that if you are given some equation, okay, like this, okay. So this is the independent variable and this is the dependent variable. You know that. This may be x and this may be y, okay. So how you draw this? You can determine the dependent variable, okay. So you can get some value like this. And you can substitute this value here and you can calculate this dependent variable with respect to this value, okay. So at t, you will get some value for xt. At t is equal 1, you will get some value to xt. At t is equal to 2, you will get some value to xt, this t. And at t also, you will get some value, okay. And here you put the independent variable. And in this axis, you put the dependent variable. And you mark this value 0, 1, 2, 3, like that. Okay. Then you mark the other values. In 0, the xt is some value. In 1, xt is some value. 2, xt is some value. 3, xt is some value, like this. Then you just join this point. No? So that is the way you draw the signal. Okay. In the same manner, MATLAB also will draw the signal like this. Okay. So very easily you can draw. Okay. So here you have to assign some value to this t. Okay. So I will assign this t from 0 to 1. 0 to let's say that 10. Okay. Like this. Okay. So here you get some 0, 1, 2, 3 from likewise up to 10. Okay. In your exam, you will not have MATLAB things. Okay. So don't worry about this. Okay. But try to get to understand this will, but this will be very important. Okay. I think at this point you should be able to plot a signal, some signal, wanted signal in MATLAB. Okay. So you can get that practice with this session. Okay. So here you will have some t value. Okay. And here you will have some xt value. Okay. Now this t is there. So this actually you will here MATLAB will create an array. Okay. Using this command, MATLAB will create an array. Okay. And for that array also, for that t, this MATLAB will calculate the xt value and it also array. Okay. So if I run this, let's say this is a modulation, AM signal or something. Should be capital Q. Okay. Okay, so you can see that you will have some t value. It is 1 to 11. It is array. Okay. So if I right click here, So these are the t values 0, 1, 2, 3 up to 10. Okay, so 11 values are there. And for that 11 values, this the MATLAB calculate the xt value like we did in our O-level maths. Okay, like we did in our O-level maths, MATLAB is calculating the corresponding value, and it is also error. Okay, so to plot this one, you can use plot command. Okay, so that is plot. Okay, so you can see that it is x and y. So normally x is the independent variable. No, in our case, what is the independent variable? It is t. Okay, and what is the dependent variable? Comma, what is the dependent variable? It is x underscore t. That is the dependent variable. Okay, so if I plot this, okay, you will get this kind of one. Okay, okay, so you can see that here with this time frame, the one circle is not complete. Okay, so see a sinusoidal wave, what can we do? Can anyone suggest? So there are many things you can do. One thing is you can extend this timeline. If you put it up to 100 or something, sometime you will get. Okay. දැන් හැබැයි තව පොඩ්ඩකින් ඕන නැති වෙනවා. හෙට මට ඕන. Okay, so you can see that you will have a sinusoidal signal, no, here. Okay, what I have done is I have just extend the timeline. Okay, so I will have some value here. Okay, so this is a sinusoidal signal, no? Okay, so you can see that it is starting here because there is a phase shift. Okay, so if I change that phase shift, let's say that I put 180 or something. So it will take some time, okay? Because my laptop is not very fast. Okay, so you can see that now it is like this, no? Okay, later it is like this. I think you can remember, okay? And now it is like this, okay? So that is, you can see that when it's the phase shift, the starting point will be changed only, okay? So that is the idea you should get here, okay? And this 5, if you give this 5 in radians, okay? So this these are in radians actually. So if you give this 5 in radians, that is 95. That is 5 by 2, no? 5 by 2. It should be like it should be a sinusoidal signal, as I have told you. Let's see. Yeah, now it is sinusoidal signal, sine wave. It is starting here like this. Okay. And if you put this 0, okay, it will be a cos signal. Okay, so it is starting from here. Can you remember that cos signal and sine signal? Sine signal normally starting from 0 like this, and cos signal is starting from the amplitude. Okay, so here amplitude is 2 now, so it is starting in 2. Okay, like this. Okay, okay. And another thing is that if you add same frequency signal, if you add same frequency to signal, okay, for example, this is, let's say that this is x1. Okay, this is x1, and I get another signal x2. Okay, and it is in another variable. Let's say that the amplitude is 6. Okay, and it is cos. Okay, and omega is here 6. No, let's say that omega is again 6. Sorry, omega is 6. Okay, plus some, let's say that some any random phase. Okay, so I get this signal x t is equal to x1. Sorry, so I add these two sinusoidal signal x2, x2. Okay. So can anyone tell me the resultant signal will be a sinusoidal signal or non-sinusoidal signal? The frequency are same, but others are different. Okay, phase and amplitude difference, these two signal, but the frequency are same. Is this resultant signal is sinusoidal signal or other signal? Can anyone tell me? I will get 10 minutes. Okay, then I can complete these things. I want to just remind the things. Okay, actually these things we have discussed previously. Okay, but I need to show you these things. These things you have learned in the signal and system. Okay, definitely. In that subject, you should learn. Okay, so tell me if you add, yeah, I got the answer. Yeah, very good. That is a sinusoidal signal. Why you said that sinusoidal signal? What about others? I got only one answer. Okay. Yeah, that is sinusoidal signal. Thank you. And how you say that it is sinusoidal signal? Give me an answer within 2 minutes. Just tell me. You can give the answer with 2 words. Why it is sinusoidal signal? There are 2 signal added together, but the resultant signal is sinusoidal. We check. So this is a resultant signal. It is a sinusoidal signal, no? Okay. Now now you can see that the amplitude change, no? The previously amplitude is 2. Now the amplitude is changed, but it is still sinusoidal signal. Okay. And can anyone tell me what is the frequency of this sinusoidal signal? Is it 6 or is it different frequency? Different or 6? Tell me. Can someone answer? Is it same or different? Actually, it is same. Okay. If you measure this frequency, okay. So try to measure this. Okay. So this frequency, yeah, same. Thank you. Very good. It is same. Okay. So you will have a same frequency. Okay. And why we have a same frequency? Because we have only one frequency component here. Okay, that is 6 hertz. Okay, only that 6 hertz frequency component is there. Okay, if you get another signal also in the same frequency, and if you add, just try. Okay, So you can get another signal with the same frequency, and if you add together, again you will get a sinusoidal signal. Okay, that is because you will have only one frequency component. Okay, that is why I told you that when I explain in the information signal, I told you that there are many different component, frequency component, no? So that it will not be a sinusoidal signal. Okay, but if only one frequency component is there, it will be a sinusoidal signal. Okay, okay. So you can simply check. Okay, so just change this uh, frequency here. Now there are two frequency components. Okay. Now the resultant signal will not a sinusoidal signal, no? So you can see that it is not a sinusoidal signal. Okay. So that is why I call you that the audio signal, real audio signal, will have several sinusoidal components, several frequency components. In other words, it has several frequency components. Okay. But for analytical purpose and calculation simplicity, we are not getting this kind of signal. Okay, we will get only we will get only uh, sinusoidal signal for the information also, but real informations are not sinusoidal. Okay, real analog informations are not sinusoidal. Okay, it has several frequency components, but for our calculation purpose and analytical purpose, we will use only sinusoidal signal. Okay, and I want to show you another things quickly. Okay, so let's say that if you multiply these two signals, so you have same frequency component. Okay, 6 and 6. Okay, and if you multiply these two frequency component, what you have? Can anyone tell me? Is it a sinusoidal signal or non-sinusoidal signal? Is it sinusoidal signal or non-sinusoidal signal? Can anyone give me an answer, please? Can anyone? Anyone know the answer? Okay, it will not be a sinusoidal signal, okay? Because this multiplication will create many frequency components, okay? So you can see that in amplitude modulation also, if you use two frequency, it will multiply. In some point, it will multiply, and you will have different frequency components, okay? So it is not happen in the multiplication. If you multiply two frequency component, it will generate other frequency component also. Sometime, okay, not always. Okay, so it will not be a sinusoidal signal. Let's check what happened. The problem. Yeah, maybe if you put that here. If you put that here, maybe it is okay. So you can see that this is not sinusoidal, no? So you can see that here it is some uh, distortion, no? So this is not pure sinusoidal. You can see that. Okay. So maybe if you change the frequency to uh, let's say that it is if we change the to frequency, maybe change. Okay, I don't know. Okay, let's try. Let's take that around 60. Okay, so only one frequency components are there, but it is multiplied. Okay, you can see that no, it is not sinusoidal signal. No, these points are different. It is not smooth. Okay. So you can see that this is not a sinusoidal signal. No? So that means what? It has several frequency components. Okay. Okay. Now tell me how we can see if you have this kind of time domain signal. If you want to see a frequency component, can you calculate that? Oh, using what? You have a very powerful tool and you have learned it in signal and system. You have to use that one also, okay? So what is that tool? It is a mathematical tool. You can find the frequency component of this kind of, these are called actually composite signal, okay? Because we add or multiply several signal together, okay? So these are composite signal, okay? If you want to find the frequency component of the composite signal, there is a good mathematical tool available. Yeah, that is Fourier analysis, Fourier transform. No? So you can use Fourier transform and find the frequency component, several frequency components. Okay. So if you apply Fourier transform this to this one, you will get two frequency component on it. Okay. So uh, so in AM, amplitude modulation also and other modulation scheme also, we are dealing with waveforms. We are dealing with signals. Okay. So time domain signals, we are normally referred as waveform. Okay. So we can see the waveform. Okay. So that is time domain analysis. And also we have to see the frequency component also. So that is frequency domain analysis. Okay. So when we are learning so next week we will learn, okay. Next week we will try to learn the frequency domain analysis and frequency domain analysis and time domain analysis of the AM waveform. Okay. So we will wind up here. Okay. So if you have time, try to get the Fourier transform of a sine signal. Okay. Try to get the Fourier transform of sine signal. And there is another part that is called modulating theorem. Okay, maybe you have learned this in your signal and system, modulation theorem. Okay, so see what is modulation theorem and try to find the Fourier transform of a sine wave. Okay, and you can plot different signal using MATLAB and check what happened. Okay, so all these are very important. Okay, so we have to apply this when we are doing the time domain analysis and frequency domain analysis. Okay, you have to apply this knowledge. Okay, so please refresh this knowledge. Okay, so shall we wind up here? I take 15 minutes more. I am sorry for that. Okay, actually we start 10 minutes more. No? Okay. 10 minutes late. No? Okay. So anyway, I take 15 minutes. Okay, I'm sorry for that. Okay, so do you have any question before winding up the session?